Imagine a cosmic horror story. Stars, in their twilight years, are revealed to be ravenous planet eaters. New research has uncovered that aging stars are far more likely to devour their orbiting planets than we previously thought. This discovery, made using NASA's Transiting Exoplanets Survey satellite, TESS, has profound implications for the fate of Earth and the rest of our solar system. Will our beautiful blue planet survive when the Sun eventually transforms into a colossal red giant? Let's delve into the details of this unsettling revelation. TESS, a powerful exoplanet hunter. You can learn more about it here. https://www.space.com/393939-test-satellite-exoplanet-hunter.html. Searches for planets orbiting distant stars by meticulously observing tiny dips in starlight. These dips happen when a planet passes in front of its star, a phenomenon called a transit. More on exoplanets here. https://www.space.com/17738-exoplanets.html. Researchers initially analyzed almost 500,000 planetary systems, meticulously narrowing down their search to a focused sample of 15,000 potential planetary signals identified by TESS. Using a sophisticated computer algorithm, they filtered these signals to pinpoint those orbiting stars just beginning their transition into red giants. This process identified around 130 planets, including 33 newly discovered candidates. This is strong evidence that as stars evolve off their main sequence, they can quickly cause planets to spiral into them and be destroyed. This has been the subject of debate and theory for some time, but now we can see the impact of this directly and measure it at the level of a large population of stars, explains Edward Bryant, a researcher from the University of Warwick. Read his statement here. https Warwick UK news press releases aging stars likely destroy their closest planets #text equals the %team %fan %that %thereby %the %university %or %Warwick. We expected to see this effect, but we were still surprised by just how efficient these stars seem to be at engulfing their close planets. But here's where it gets controversial. Are all red giants equally destructive, or are there specific factors that make some more prone to planetary cannibalism? It's a question scientists are actively investigating. So, what exactly triggers this stellar transformation? Stars become red giants when they exhaust the hydrogen fuel in their cores. This means they can no longer sustain nuclear fusion, the process of converting hydrogen into helium that powers stars like our Sun. When this happens, the star's core begins to contract, while the outer layers, where hydrogen fusion still occurs, dramatically expand. This puffing out causes the star to swell to an enormous size, sometimes up to 1,000 times its original diameter. This marks the end of the star's main sequence phase and the beginning of its red giant phase. Obviously, this extreme expansion is bad news for any planets orbiting close to the star. For example, when our Sun enters its red giant phase in approximately 5 billion years, it's projected to expand and engulf Mercury and Venus, and potentially even Earth. And this is the part most people miss: direct engulfment isn't the only danger. The team believes that red giants also employ another destructive mechanism. We think the destruction happens because of the gravitational tug-of-war between the planet and the star, called tidal interaction. As the star evolves and expands, this interaction becomes stronger, Bryant elaborated. Just like the moon pulls on Earth's oceans to create tides. Learn more here. https://www.space.com/55-earths-moon-formation-composition-and-orbit.html. The planet pulls on the star. These interactions slow the planet down and cause its orbit to shrink, making it spiral inwards until it either breaks apart or falls into the star. This tidal interaction is a subtle but powerful force that can doom planets to a fiery death. This destructive trend is supported by the team's findings. When they focused on stars that had already begun to expand, they observed a significantly lower chance, only 0.11%, of those stars hosting a planet compared to main sequence stars. That's roughly 3% lower, a statistically significant difference. Furthermore, the researchers found that the probability of a red giant hosting a giant planet like Jupiter or Saturn also decreased with the star's increasing age. This strongly suggests that planets are indeed being consumed or ejected as stars age. But what does all this mean for Earth's long-term survival? Do we have a fighting chance? Earth is certainly safer than the giant planets in our study, which are much closer to their star. But we only looked at the earliest part of the post-main sequence phase, the first 1 or 2 million years of it. The stars have a lot more evolution to go, explains Vincent van Allen, a researcher at University College of London. Unlike the missing giant planets in our study, Earth itself might survive the Sun's red giant phase. But life on Earth probably would not. So, while our planet might physically endure, the conditions will almost certainly become uninhabitable long before the Sun reaches its maximum size. The researchers are now focusing on gathering more data to better understand what makes some planets vulnerable to these elderly, planet-eating stars while others manage to escape. This investigation could provide crucial insights into Earth's potential fate. What factors determine whether a planet becomes a cosmic snack or a survivor? Once we have these planets' masses, that will help us understand exactly what is causing these planets to spiral in and be destroyed, Bryant concluded. Understanding the masses of these doomed planets will allow scientists to refine their models and predict which planetary systems are most at risk. The team's groundbreaking research was published in the October edition of the monthly notices of the Royal Astronomical Society, https://academic.oupr.com/mnras/1/4/11864/8286899. What do you think? Does this new research make you more concerned about the long-term future of Earth? Do you believe we should prioritize research into planetary defense strategies, even if the threat is billions of years away? Share your thoughts and opinions in the comments below.